Perpendicular bisector, a line that intersects a given segment at a 90-degree angle and passes through the given segment midpoint. Perpendicular bisector theorem. If there is a point on the perpendicular bisector, it is congruent from both endpoints of the segment. Therefore, since this is a perpendicular bisector, this point on the line is congruent to both of these endpoints. Converse of perpendicular bisector theorem. If a point is congruent from the endpoints of the segment, then it is a perpendicular bisector. Therefore, if this point is congruent to both these sides, then you know this is a perpendicular bisector. The concurrency of perpendicular bisectors theorem. Perpendicular bisectors of the sides of a triangle are intersected at a point equally distant from the vertices. Therefore, since all these perpendicular bisectors meet at the circumcenter, which is where all the lines meet, then all of these lines are congruent. So this one, this one, this one are congruent, and this one, this one, and this one are congruent. Then one of our practice problems was to find the value of x. So if you were given all this information, what you have to do is, since these are both going to be equidistant from the circumcenter, you have to set them up so they're equal to each other and then solve to find x, which we found to be x equals 2.
Angle bisectors. A right whose endpoint is the vertex of the angle and which divides the angle into two equal angles. This will make angle ABD congruent to angle DBC. Angle bisector theorem. If a point is on the bisector of an angle, then the point is equidistant from both sides of the angle. This will make line CA equal to line BA and line BC equal to line BD. Converse of angle bisector theorem. If a point in the interior of an angle is equidistant, then the point is on the angle bisector. For this practice problem, you can use the angle bisector theorem, which means AC will be equal to AB because the bisector, so X will equal 10, and BD will equal DC because the angle bisector line, so Y will equal 5.
Hello everybody! Today we're doing triangle mid-segments, one of my favorite sections of all of geometry. So first we're going to start with the theorem, which is the corollary to triangle mid-segment theorem. If the segment joins the midpoint of two sides of a triangle, then the segment is half as long as the third side of the triangle. So you're probably wondering, what does this mean? Well, I'll show you an example that I wrote down here. It says, what are the lengths of MC, line AC, and EN? So, this is already filled out, but I'm going to show you how you would find these lengths. So, if this bottom part is 60, then this middle part would be 30, because it is always half of that side. So then this over here, if this is 40, this would be 20. Hello everybody! I'm back with part 2 of triangle mid-segments, and we're here with the second theorem. We saved the best for last. It's triangle mid-segment theorem. And I'm going to read this for you. It's right here if you want to read along. If a segment joins the midpoints of two sides of a triangle, then the segment is parallel to the third side of the triangle. So, you may be baffled, you may not be, but I'm going to show you this example either way. So we have triangle JEN here, and we are solving for x. So we have 10 on the bottom, x in this middle part, and what would you do? Well, if this is always half of this base part, and this is always 2 times this part, We can find this out by taking half of 10. So the answer would be 5. Any more questions? You can follow me on my website. Bye for now.